Hello my dear friends, welcome back. I hope all of you are doing well and doing well with your studies too. Let's continue with our exercise. That's exercise 7.3 with permutations. As I mentioned earlier also, this is a very important chapter, a very important topic for your future examinations also. But this textbook actually doesn't provide us enough. So I definitely will need some other textbooks also to practice, because by just solving this few 11 odd questions, I don't think you should be confident to say that okay, I'm done with permutations. No. So you can follow us on Instagram. I will be uploading there are many theorems, many shortcut formulas, many theorems, circular permutations are there, restricted permutations are there. You can follow us on Instagram. I'll be uploading the formulas very soon. So you can note down and then of course keep that for your future reference, and which will help you in your preparation for your JEE. JEE also. Let's come back. We will try to relate the formulas also, but we'll try to understand and solve each question individually. So I will be solving this exercise in my own way. Okay, so let's begin. Like the first question is like, in how many ways, how many 3-digit numbers can be formed by using the digits 1 to 9? We have 9 digits, 1 to 9, if no digit is repeated. Now you see, we have to form here 3 digits. And you can choose them from the digits 1, 2, 3, 4, 5, 6, 7, 8, 9. It's quite simple. Condition is you cannot be repeating any of the digits. So now let's just do it very quickly. So now let's say in the units digit, tens digit, hundreds place. Now in the units digit, in the units place, let's say in the units place, let's say the units place. The units place can be filled up in how many ways? Because first one, so no restriction, we have 9 digits with us, so it can be filled in any one of the 9 ways. So it can be filled in any one of the 9 ways. Now, the tens place can be filled up in, now here one digit is already taken. So that means we have how many options? We have 8 options which can be filled up in any one of the 8 ways. So it can be filled up in 8 ways. So see, without using the formula, simple logic also will just help us solve the problem. So it's not necessary, no, not at all, okay. We can just do it in our own ways. And similarly, the hundreds, HUNDREDS, the hundreds place can be filled up in how many ways? So here 9 digits we had, we could use any one. Since it is not, repetition is not allowed, we have only now 8 digits because one is already taken here. So we have 8 digits, that's also done. So that means here now we have only 7 digits because 2 digits are already used, repetition is not allowed. That means we have 7 ways. Now by multiplication principle, what will be the total number of ways in which the 3-digit number can be formed? The total number of ways, all this arrangement can be what? 9 into 8 into 7. So that's of course basically actually 9p3. Okay, this 9 factorial, 9p3. Of course, I mean for those who wish to use the formulas and then just calculate, that will be same as 9p3 ways. Of course, I'll be giving you a shortcut by the end of this video. So stay tuned. Of course, please, you can start noting down. So that's of course 9 into 8 into 7. You can just check out the formula there, 9 into 8 into 7. The value, that's of course going to be 504 ways. 504 ways. Okay, so that will be of course equivalent to 9p3 ways. You'll be getting the same answer there also. Okay. Alright, so I guess that's done. Let's move on to the second question quickly. The second question says, how many 4-digit numbers are there when no digit is repeated? It's almost the same question like number 1, just that the question is how many 4-digit? How many 4 digits can be formed by using, how many 4 digits are there with no digit repeated? How many 4-digit numbers can be formed? I can just like write it like this, like with slight change. How many 4-digit numbers are there? How many 4-digit numbers are there? How many 4-digit numbers are there with no digit repeated? How many 4-digit numbers are there with no digits repeated? Now, you have to be careful here. Because in that first question, we had the digits from 1 to 9. So there was literally not many restrictions there. Here, of course, actually in reality, how many digits do we have? We have like 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So we have like 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in total, of course, we have like, there are 10 digits from 0 to 9. So we have actually 10 digits from 0 to 9. Now we have to form a 4-digit number. That's like units place, tens, hundreds, thousands place. Now there's one condition here, because to form a 4-digit number, 0, 4, 3, 2, like for example, 4-digit number. Now let's say 0, 4, 3, 2. Now this is not a 4-digit number because this is like 432. Now 432 is not a 4-digit number. That means you can't write 0 in the front, but I can use this 0 anywhere, like 4302 or 4320. But this 0 can be used, of course, anywhere. I hope you're getting my point here. This 0 can be used anywhere except in the first place, because like 0999. How much is this? We counted as 999, so that's only a 3-digit number. So I can't use 0 up here in the front. That means at the thousands place, I will have only 9 options. This means options, okay? By writing the number 9, I mean 9 options, not the number 9. I have like 9 options. So we can write some restrictions. We can write along with me quickly. So like the thousands place cannot be 0. So it can be filled in 9 ways, like 1 to 9. This is just for you, okay? It can be filled in 9 ways. Now that's sorted out, fine. Now the problem is no digit is being repeated. That means here I will be using any one of the digits. I will be using any one of the digits except 0. But now, just for example, maybe I have used 2. Just for example, I have used 2. Now to go, it's okay, you can go this way or this way, you know. But since we have to be careful with 0, I'll begin from here. Now in the hundredth place, how many digits are there now for you to use? Because see, one of the digits is already used, which cannot be a 0. Please take note of that. So maybe I may have used, let's say, 2. So in that case, how many digits are left with me now? 1, 2, 3, 4, 5, 6, 7, 8, 9. That means in the hundredth place, I have 9 options. I can use 9 options. So I can use any one of the 9 options. So the hundredth place can be filled in 9 ways. Can be filled in 9 ways. Okay, no? Now similarly, almost similar. After this, it's almost similar like the previous question. Now in the tens place, see, let's say for example I've used 4. Let's say for example I've used, okay, no problem, I've used 0. Now I have already used 0, I have already used 2. We can use any number, but you will always find this arrangement only. Now how many options are left? 1, 2, 3, 4, 5, 6, 7, 8. It is all because what? All because no digit is repeated. That is a restriction here. So then the tens place can be filled in now how many ways? 8 ways. Now similarly here, how many options? I hope you have got it. We have now here 7 options. Let's say here I use 1. So this is also out. So 1, 2, 3, 4, 5, 6, 7. So the units place now can be filled in how many ways? 7 ways. But each of this, of course, we can be using any one of the numbers, isn't it? So in that case, what will happen is the multiplication principle will be used. I hope you've written down. I'm rubbing it off. So total ways. Total, not ways, like say total 4-digit numbers. Total 4-digit numbers will be, first one, 9 ways. So that's 9 into 9 into 8 into 7 ways. So you can calculate that, 9 into 9. So that's 9 into 9 into 8 into 7. So that's going to be 4,536 ways. 4,536 ways. These are the number of arrangements in which we can have these 4-digit numbers. Let's move on to the third question then. Let's see what we have there for us. Third question says, how many 3-digit even numbers? How many 3-digit even numbers can be made using the digits 1? Okay, question number 3. Another question is, how many 3-digit numbers this time? How many 3-digit numbers? How many 3-digit numbers? Units place, tens place, hundreds place. How many 3-digit numbers can be made using the digits? Okay, we have here limited digits. 1, 2, 3, 4, 6, 7. 4, 6, 7. How many 3-digit even numbers? Question is now again, condition is even numbers. Even numbers. More restriction here. Even numbers can be made using the digits if again no digit is repeated. Another condition is like no digit is repeated. So again, repetition is not allowed. No problem. Now, for a 3-digit number to be an even number, there's only one restriction where we have to be careful. That is the last units place digit. The last units place digit should end with an even number for that 3-digit number to be an even number. Simple as that. So how many options do we have with us? We have here 1, 2, 3. We have here 3 options. It can be any one of the 3. So let's say for the 3-digit number, to be even, the units place has to be either 2 or 4 or 6. So it can be filled in how many ways? It can be filled in 3 ways, because we have only one position to be filled up, but we have 3 options. So either 2 or 4 or 6. Now let's just say that we have used 6. That always helps, okay, to solving with an example. Now, then, the rest is quite simple. Then the tens place. These are just playing with numbers, no? Then the tens place can be filled in how many ways? Now for the tens and hundreds, it's whether it's even number or odd number, that's really not our concern. Now let us assume that we have filled it up with the number 6, the last digit. So now, for the tens place, how many options do we have left? 1, 2, 3, 4, 5. We have 5 options. So now that means it can be filled in 5 ways. Is that clear? So let's use another number here. Let's say I used 7 out of the 5 options. So 7 option also gone. Remember, repetition is not allowed. And the units place can be filled in, now how many options? 1, 2, 3, 4. Can be filled in 4 ways. So how many options do we have? So total let's say total ways will be what? We have here 3 into 5 into 4. So that's going to be what? 5 4s are 20 into 3. That will be in 60 different ways. We can form that 3-digit number, provided that the last digit is even number, so that the 3-digit number can be an even number. Alright, note it down, no? You can just pause the video there. Okay. Let's go to the question number 4. Let's quickly solve the question number 4. Okay, let's be quick. Find the number of 4-digit numbers that can be formed by using the digits 1, 2, 3, 4, 5 again. Again, we have to get a 4-digit number. 1, units, tens, hundreds, thousands. Using the digits, of course, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So that 0 problem is not here. Using the digits 1, 2, 3, 4, 5, if no digit is repeated, then of course that can be done very quickly. That is number 4. So we have already done similar questions. So the number of 4-digit numbers that can be formed. So let's start with the units place. So I'll just write it in short. You can just write it in an elaborate way, the way we have written. So units place can be, it's actually 9p4. 5p4 ways, 5 into 4 into 3 into 2, you'll get the answer. But let's write down and understand. And later on, once it is done, you can start using the formulas also, no problem with that. I'm just explaining in the full context, okay? So units place can be filled in how many ways? We have 5 options, in 5 ways. Tens place. So tens place can be filled in, let's say I've used one number, let's say 4. So tens place can be filled in now 4 ways, in 4 ways. Similarly, hundreds, I'll write in short, hundreds place can be filled in how many ways now? 3 ways. Let's say I've used 3. Now I have 3, so thousands place can be filled in how many ways now? Units place, I've used 4, 3, let's say hundreds place, I've used, let's say 2. This is also used, so I have only 2 options that can be in 2 ways. So total ways, that's 5 into 4 into 3 into 2. As I mentioned, that's simply 5p4. No restrictions, only that the digit is not allowed, so permutations we prefer that only. So 5 4s are 26, that's going to be of course 120 ways. Alright, now there's another part of the question, that is how many of these will be even? How many of these will be even? That's the second part of the question. How many of these will be even? We have already done. For the 4-digit number to be even, the last digit has to be, how many options do we have here? So we have to restart once again. So the last digit, 1, 2, 3, 4, 5. So the last digit has to be either 2 or 4. That means which can be done in how many ways? Which can be done in 2 ways. Which can be done in 2 ways. So let's say I have used, let's say 2. So now we have 3. Then the remaining 3, I'll just write directly 3 places, that's the thousands, hundreds and tens place. Then the remaining 3 places can be filled by any of the 1, 2, 3, 4, by any of the 4 digits. In how many ways? We have 4 digits, 3 places to fill, that's 4p 3 ways. So that's 4 into 3 into 2 ways. So that will be what? 4 3s are 12, 12 2s are 24 ways. So in that case, the total ways will be what? This one, that last digit is fixed. It can be done in 2 ways. Remaining can be done in 24 ways. So we can fill it out in how many ways? 48 ways. Simple as that. Okay? 48 ways. Alright? Okay, now I forgot to mention one formula regarding these permutations. See, as I have written here, no? Permutations. I'll give you one formula that is shortcut. See, NPR for P3, you can use 4 factorial by 4 minus 3 factorial. That's going to be 4 factorial by 1 factorial. So that's like 4 into 3 into 2 into 1. That's the way we use the formulas. But directly also, I'll give you a formula which will really help you save a lot of time. That is, for example, let's say 4p2 ways. So all you have to do is expand 4 2 times. Go for the factorial of 4. Expanded product just twice, 4p2. That means 4 twice, 4 into 3. That means, let's say 7p3. In that case, I'll expand 7 3 times in the decreasing order. 7 into 6 into 5. You're going to get the same formula only. Alright? That means if it's np4, that means I will expand n how many times? 4 times. So that's n minus 1, n minus 2, n minus 3. No factorials, nothing. It's all done. It's all sorted out. These are shortcuts. So it's like 1, 2, 3, 4. 4 times I've expanded the product. So let's try to use this. Okay, that will be helpful for us. Okay, moving on to the next question, that is, from a committee of 8 persons, question number 5. From a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman, assuming that one person cannot hold more than one position? From a committee of 8 persons. From a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman, assuming that only one person, one post. One person cannot hold more than one position. So that's like no repetition is allowed, isn't it? If I'm the president, I cannot be vice president also. So we have 8 people fighting for that post. So that's quite simple. So the principal, or what was it? Chairman. The chairman can be selected in 8 ways, because when you go for the chairman, we have 8 options, so the chairman can be selected in 8 ways, no restrictions there. But the vice chairman can be selected in how many ways now? Because we have here 8 persons, so one of them is already selected as a chairman. So then how many people are left? 7 people, because the one who is selected for the chairman is done. Out. You are the chairman, get out, move aside. Now let us go for the vice chairman. So he cannot hold 2 positions. So that means we have only 7 people left, one of whom can be the chairman. So that means we can have 7 options. Bus. Oh yeah, so total ways, that's 8 into 7. So that's going to be how much? 56 ways. Got it? Alright, let's move to a more algebraic one. I'll solve one of them. That's like question number 6. Question number 6. Let's try to finish this video, this exercise in this one video itself. Question number 6 is, find n if n minus 1 p3, the ratio with np4 is 1:9. So that's about algebra simplification. Let's quickly solve. So n minus 1 p3, as per the question, that's np4, that's 1/9. Let's solve. So, okay, I'll just expand the formula. That is n minus 1 factorial, n minus 1 minus 3 factorial, whole divided by n factorial, n minus 4 factorial, 1/9. So that's n minus 1 factorial, n minus 4 factorial upon n minus 4 factorial, cross multiplying, dividing n factorial 1 is to 9, so n minus 4, n minus 4. N minus 1 factorial, I will expand this n factorial now here, okay? So n into n minus 1 factorial, so that's going to be 1 by 9, n minus 1, n minus 1 done. We have 1 by n is equal to 1 by 9, that implies of course n is how much? 9, simple as that. Okay, no? That's quite simple. Let's move on to one question again. That's, let's say, one more question from 7. Find R. If the first question is 5PR is supposed to be equal to twice of 6PR minus 1. Be careful, be careful, be careful here, okay? Now let's expand 5 factorial upon 5 minus r factorial 2 into 6 factorial 6 minus r minus 1 whole factorial. Most of the students they make the mistake here. They simply write 6 minus r minus 1. Formula was what? If you remember, NPR formula is n factorial n minus r factorial. What is the value of r here? The value of r is r minus 1. So it's going to be minus of r minus 1. Bracket or off. So that's going to be really very careful. I mean, you have to be really very careful there. Okay, my dear students. Do not lose marks for your silly overconfidence. So let's simplify this. 5 factorial. 5 minus r factorial. 2 into 6 factorial, I'll just expand. 6 into 5 factorial. 6 minus r plus 1. Okay, I'll just write 5 factorial, 1 times 1 times 1 by 5 minus r factorial. 12 by 7 minus r factorial. So that's 1 by 5 minus r factorial 12 by, I'll expand this, bigger value only I can expand, 7 minus r, 7 minus r minus 1, that's going to be 6 minus r, next 5 minus r factorial, 5 minus r factorial, so 5 minus r, 5 minus r, so here 1 by 1, 12 by 7 minus r, 6 minus r. So cross multiplying 12, 7 minus r, 6 minus r, 12, 42 minus 13r plus r square minus 12 equal to 0. R square minus 13r plus 30 is equal to 0. Splitting the middle term factorization I will do. For those having any problems with splitting the middle term, there is a video which I have prepared for factorization. You can check out the link which I will provide below. Okay, you can check that and revise. R square minus 10 r minus 3r plus 30 equal to 0. Please make sure that you do your studies regularly, my dear children. Otherwise, you will regret, because don't assume for a second that if you are studying, your friends, if you are not studying, your other friends are not studying. I wouldn't be so sure of that. Everybody has to take care of their own business. Everybody has to be careful, take care. They have to take care of their own lives. You will have to take care of your own lives. Alright, now with the solution, I have got two values, r is equal to 10, r equal to 3. There is one problem here with one of the values, that is r equal to 10 here, because as per the question, we have factorials of 5pr, and the other one is factorials, permutations, 6pr minus 1. Now for example, if r was 10, just for example, if r was 10, we would have 5p10 here itself. This one is not even needed then in that case to decide. Now that is not possible, isn't it? Because we have mentioned before that for npr, n should always be greater than r, or yes, n should always be greater than r, or at the most equal to r. So here now 10 is greater than 5, which is not possible. This should always be greater or equal to, at the most. This cannot be greater. So in that case, r equal to 10 would not be possible. So that means our value r would, the required value for us would be r equal to 3. Okay. Alright, now let's move on to another question. That's, let's say, the second question, you can give it a try, that's all the same. Question number, let's say, 8. Let's do all the as much as possible. How many words with or without meaning can be formed using all the letters of the word equation? Are there any equal letters there? E, Q, U, A, B, Q, U, A, P, I, O, N. I'll be giving you another theorem here. Please be with us. Using each letter exactly once. That means no repetition is allowed. So that makes our job very, very easy. So that will be, the question is very simple. That is, how many words with or without meaning can be formed? So how many letters do we have here? There are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 letters. Actually, all different. So all different with or without meaning. In how many ways can be formed? How many words can be formed with or without meaning? That means all these 8 letters can be just arranged and meshed up. One here, one there. We can do it in so many ways. In short, they can be arranged. One good condition is that none of the letters should be repeated. So that's why it is much easier. Can be arranged in how many ways? 8p8 ways. So 8p8 ways, of course, that's 8 into, as I said, 8p8. Expand 8 times. 8p8. 8 into 7 into 6. 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8. We can find out the value of the product there. So that's going to be 8 into 7 into 6 into 5 into 4 into 3 into 2. So that's like 40320. 40320. Alright, okay. Alright then, so that's it. Let's go to another question. Okay, let's do one more question, that is number 10. That is going to be important for us. Number 10. In how many of the distinct permutations of the letters Mississippi do the 4 I's do not come together? Do the 4 I's do not come together? Now for this, of course, I will be giving you a theorem. So you can take out your book, copy, start noting down the formulas. This is the theorem. You can write down that let there be n objects. Let there be n objects of which m objects are alike, of one kind, and the remaining n minus m objects are alike of another kind, then the total number of mutually distinguishable GUIS mutually distinguishable permutations that can be formed from these objects is n factorial, very important, m factorial into n minus m factorial. This actually formula can be again extended also if you have m objects of one kind, p objects of another kind, q objects of another kind. We have 2, 3 kinds, so it can be n factorial by m factorial upon p factorial into q factorial. That of course it will continue. That's why, as I said, now there are many formulas which definitely I will be uploading very soon. So I guess this done. We can note down. This will be required for our question. I repeat the question once again, the theorem once again. That is, let there be n objects of which m objects are alike of one kind, and the remaining n minus m objects are alike of another kind. Then the total number of mutually distinguishable permutations that can be formed from these objects is n factorial by m factorial into n minus m factorial. Can be extended also if there are more than 2 terms which are alike. Okay, so let's go to question number 10. That is, in how many of the distinct permutations of the letters in Mississippi, M-I-S-S-I, P-P-I. So that's what I mean, no? Do the 4 I's do not come together? Let's talk about that later on. Do the 4 I's do not come together? So, in the word, there are how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 letters where there are 4 S, 1, 2, 3, 4, 4 I's, and 2 P's. So 8. Only M is alone here. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. Now the question is, in how many ways of the distinct permutations of the letters in Mississippi do the 4 I's never come together? Now that's really going to be a big task for us. They never come together. That means the 4 I's always are in this way. They never come together. So we have only one option, that is, chalo, find out all the arrangements. Now with 11 letters, are you ready for finding out all the arrangements? So that's really going to be tough for you. So that's what we are not going to be doing. That's where we will use permutations. What we can do is, listen carefully, what we can do is, we'll find out first the total number of permutations in which the word Mississippi can be arranged, just like the previous question for equation. Total number of ways in which the word Mississippi can be rearranged among themselves with or without meaning. Total ways. Okay. Then, after that, what we will do is we will assume that the four i's always come together. That's always going to be an easier way. Okay, that's always going to be an easier way. So we will assume that the four i's, because to never come together, we have only one option, that is find out the number of arrangements. You go on arranging and that might take you the whole day, maybe 1 week also. So what we will do is we will just bring all the i's together. I'll show you how it is done. So we will bring all the i's together and we'll find out the number of ways in which the four i's can come together. Okay, so definitely that's always going to be lesser. And we will subtract that from, so this is the four i's together, from the word Mississippi, where all the letters can be arranged in different ways. Out of that, we are grouping these four i's together, and let's find out the number of arrangement in which these four i's will always come together. Remove that from the total number of arrangement. We will be left with the arrangement of the word Mississippi, except for the case where the four i's come together, and that is really going to solve our question, that is the four i's never come together. Okay, how? You might still be confused, but don't worry, this is how we are going to be doing. Like, look here. Now, total ways in which the word Mississippi can be arranged among the letters, among themselves, will be equal to, so we are going to use that previous formula, total number of ways in which a letter can be arranged with or without meaning when there are repetitions. That was n factorial by m factorial, p factorial, q factorial. As I said, no, it can be extended. Q, R, U, A can go on. So here, of course, n is 11 factorial. M, we have 4s, 4 i's, and 2 p's. Remember, it can be extended further also. Okay. So that, of course, I will not be calculating. That, of course, you can calculate, and that actually gives us the value. You calculate that, please. 34650. 34650. I calculated that in advance so as to save some time. That is 34,650 ways. That means the word Mississippi can be arranged among themselves without any restrictions in 34,650 ways. One job done. Now, let us assume that the four i's always come together. That means four i's always come together. So in that case, how many letters are left? 4 minus 8. 4 minus 11, that's going to be 7 letters, remaining letters. That means if we just consider this as one letter, no, we are just tying them up, always grouped together. So all these i's, 4 i's, as one letter. So in that case, actually, if we just consider this as one word, and these are 7 remaining letters, we will have how many letters left with us? We will have 8 letters left with us. Got the condition, no? Assuming that what? The 4 i's, of course, always come together. Please, let's not forget that. So what we are doing is we are grouping the 4 i's together. Okay? We are grouping the 4 i's together and considering them as just one letter. So in that case, plus the remaining 7 letters. So in that case, of course, we will have 8 letters. So if we just assume that the 4 i's always come together, then we have this 4 i's, that is 1 plus 7 letters. So that's in total 8 letters. Got it? No? Assuming that 4 i's always are together. So total ways in which this can be arranged will be what? 8 factorial divided by 4 i's now are just considered as one letter. So that means only s is repeated 4 times and p is repeated 2 times, because I is just considered as one letter, always coming together. So this of course will give us the value 840. 840 ways. So now we have the total number of ways in which the word Mississippi can be arranged in 34,650 ways. Out of that, 840 ways are the number of ways in which the 4 i's will always come together. The question is, in how many ways will the 4 i's never come together? Got it, no? So total ways in which the 4 i's never come together will be 34,650 minus 840 ways, and that will be 34,650 minus 840 ways, so that will be 33810. 33810. 33,810 ways. Okay, let's do one more question. I hope you are, thank you for your patience, but let's do one more question. Well, all these questions are important. I want to finish it all. Chalo. Interesting question again. Number 11. Again, here also we have Permutations. Permutations can be arranged. Now, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 letters in which any repetition here. Okay, T is repeated twice, in which T is 2 times. I guess that's all. Any more again? Yeah, that's all. In which only, of course, here T is repeated 2 times. No problem with that. Okay, number 1. The word starts with P and ends with S. Permutations. Now that's fixed. We can't do anything with that. P. So this can be done only in one way. And this can be done only in one way, because we have only single letters. So P can be just fixed here, S can be just fixed here. That means the remaining letters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 can be fixed in how many ways? From the remaining 10 letters. But remember, T occurs twice, so we have to use that theorem which I had given to you earlier. Okay, so we can write down total number of ways will be what? 10 factorial divided by simple 2 factorial. Simple 2 factorial. It's simple as that. We have 10 letters which we have to arrange. These are fixed, one way each, divided by, of course, 2, because T is repeating twice, the theorem that I gave you. So of course that, if you calculate, then let's see how much do we get. You can use your calculators. That is 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 divided by 2. So that's going to be 181 4400 181 4400 ways. Alright? Okay, that was a simple one. Can I rub it off? Yeah. Next. The next question is, vowels are always together. The next question says the vowels. How many vowels are there? E, U, A, I, O are always together. The vowels are always together. The vowels are always together. So remember, just like the last question, that means they can be arranged in previous. This time is they are always together, so we don't have to subtract because they are always together. So directly we get the answer. If they are not together, so in that case only we find out for together, remove that from the, subtract that from the total. That's what we have. Number of ways in which they are never together. This time they are always together, so they can be arranged in E, U, A, I, O. That's 1 plus E, U, A, I, O plus remaining letters. How many letters in that case? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. 7 ways. So 7, 8, 9, 10, 11, 12. Plus 7. So of course they can be arranged in, of course, 8 ways. Not they can be arranged, no, that means they can be assumed. They can be assumed to be 1 plus 7, 8 letters. But this time 5 vowels can be arranged among themselves in 5p5. That will be 5 factorial ways, because here we have, earlier there was only 4 i's, same i's, but here we have different letters, so again they can be arranged among themselves again in 5p5 ways, 5 factorial ways. Alright, so we have 8 letters to arrange and 5 vowels to arrange among themselves. So in that case, total ways will be 5 factorial into 8 factorial divided by 2 factorial. Why 2 factorial? Because t is repeated twice, so we are going to be using that theorem. Okay, so here of course I will not calculate, it will take some more time again. So here of course the value would be 2419 2419200. You can please check out the value and then of course do let me know. That will be 2419200 ways. Alright, okay, now the last one. Alright, the last one says there are always 4 letters between P and S. Chalo, if we start with P, 1, 2, 3, 4, S. So 1, 2, we have how many? 12 letters, no? So okay, let me just write down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2. 1, 2, P. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, P. 1, 2, 3, 4, S. Because there has to be 4 letters in between them. That of course will not take time. If we just give a little bit, if we just have patience, it can be done like this very easily. But of course this is not a solution. This is just a small part of the answer. 1, 2, 3, 4, 5, 6, P, 1, 2, 3, 4. Now beyond this I cannot move, because if I go here P, then we have only 12 letters to arrange. So up to this only I can manage, because if I next is 1, 2, 3, 4, 5, 6, 7. If I start P, 1, 2, 3, 4, then there is no space for S. Alright, so this of course is not possible. This is where we wind. Now this P and S can be arranged like this in how many ways? P can happen in 7 ways, S can occur in 7 different positions. So that's like the letters P and S can be arranged in 7 plus 7, that's of course 14 ways. So that's just P and S. Now, alright, now when we do this, what happens is the remaining letters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are still 10 spots left. I'll be rubbing off the remaining values. I hope you have written it down. You can pause. Yeah. The remaining 10 spots can be filled up again by the remaining 10 letters. P and S only fixed, but the remaining 10 letters can be rearranged among themselves in how many ways? The remaining letter ways, but don't forget T is repeated. So let's, in that case, the remaining letters can be filled in 10 factorial divided by 2 factorial ways. 10 factorial by 2 factorial ways. Alright? 1814400. So, total number of ways will be 10 factorial by 2 factorial into 14. So that's going to be how much? Into 14. So that's going to be 2540, 1600 ways. Total number of ways. Alright, fine then. So this would be the end of the exercise. Quite a long exercise, but of course very interesting question. We can actually do it without the formula, use of the formulas directly also. It can still be solved with our common sense also. So that's why these topics are used so much, in competitive examinations. Alright, I hope you have liked the video. Please, thank you for your support. If you have not subscribed, please do subscribe. And yes, I'm very near to going live. Please, I will need your support. Please kindly share with maximum of the students who are still unaware of this channel. Alright then, see you. Take care. See you with combinations.